All right, everybody. So this is the cell cycle control game, and what I'm going to do is I'm going to go through it for the people whose technology is preventing them from playing the game. I've gone to the site. Next thing I'm going to do is I'm going to go ahead and click on the cells. It says to see what happens. So I clicked on that cell, and wow, look at one cell into two. Interesting. And they're getting bigger and bigger and bigger. All right, let me try it again. Click on that one, and one more time. We got cell division. We can see that little needle going around and around on that gauge of the cell cycle there. And if I keep clicking on stuff, you can see I can make all these cells start dividing. And since this game is called the cell cycle control game, that makes sense. Okay. All right. It says after you watch the cells, click enter to get in the game. Do that now. All right. It says answer the following questions. When do the cells divide? That's number one. Okay. Well, if I look at the little, let me stop him from snoring for a second here. Oh, I can't. All right. But you can see all organisms are made of cells which constantly divide and multiply. Cells divide when they need to replace injured or dead cells or as part of the development of a fertilized egg. 300 million cells are replaced in our body every minute without ever noticing. All right, well, there's an answer you might be looking for, okay? So you may want to pause the video on that to answer it. All right, and it gave the answer number 2 as well. All right, click on the arrow to divide. Number 3, cells divide at different rates. Okay, so he wants you to complete the statements for A, B, C, and D. Let's see what the caption says. Different cells divide differently. Skin cells divide very often. Liver cells divide sometimes. Cells in the bone marrow and cells lining the stomach and intestines continuously grow and divide throughout a lifetime. So I think there's some answers there for 3. Click the arrow to continue. It says when a cell dies, what happens? Okay, so we just had a cell die. All right, looks like it breaks up. It leaves an empty space in the tissue. This signals nearby cells to start dividing in order to fill the space. A receptor in the cell's membranes pick up the signal, send it through to the cell nucleus, and the process begins. All right, I'm going to move on to number 5. It says click there to continue. What 2 key molecules that control and coordinate the cell cycle? That's what I'm looking for. All right, cell division follows a specific pattern called the cell cycle. This cycle illustrates the different phases of division. The key molecules that control and coordinate cell division are called CDK and cyclin. All right, then it says click the arrow to continue. Enter the cell cycle control systems by clicking on the door. All right, let's do that. All right, so welcome to the cell nucleus. You are our new cell division supervisor. A nearby cell has died and we need you. Please come on in. All right. Message from outer space. Cell death in tissue. Cell division signal has entered the cell. New cells required immediately. All right, well, it says select... read the information and select the event that must occur in G1 of the cycle. Okay, so what has to happen here? Do we need to destroy more cells? Do we need to divide these cells? Do we need to grow these cells? Do we need to separate the chromosomes or duplicate the chromosomes? Yikes. Well, let's see what happens if we divide the cell. Nope. So if we're not dividing the cell, I guess we got to make the cells that are nearby a little bit bigger. Let's try that. Green light. All right. The cell has entered gap 1 phase in the cell cycle. Cell cycle has started. Cell at highest energy level. All right. It says read the information on the left screen. What 2 things must occur for the cell to proceed in the S phase of checkpoint 1? So clearly cell size matters and genetic material matters. Let's look into those a little bit more. Looks like our cell is being scanned. cell size increased by 20%. Checking completed. Cell big enough to proceed in the cell cycle. All right, let's try this one. Our nucleus is being scanned. Genetic material checked. No damage found. Checkpoint cleared. Proceed in the cell cycle. Okay, so let's see here. Read the information on the right and select the event that must occur. All right, so now we've got to find, I'm on 11, what must occur in the S of the cell cycle. And we know that we got to duplicate chromosomes in synthesis, right? Yes, we do. Cell is entering synthesis phase. Duplication of genetic material has started. Look at the nucleus. And everything in there just doubled. All right. So we're now in G2. Says cell is now proceeding at G2. Read the information on the control screen to the right. Select the event that must occur in G2. Well, we know in G2 that we got to do more growing because it's a growth 2 phase. So we enter there. We got a green light. Continued cell growth. Look at that. The cell got a little bit longer from left to right. Now we reach checkpoint 2. Read the information on the left screen. What 3 things must occur in order for it to proceed in G2? All right, let's check. All genetic material duplicated. It's checking it. Making sure that those chromosomes got doubled correctly. It says, yes, please proceed. Let's check cell size. All right, cell is big enough to enter next. Proceed. All genetic material intact. All right, so it checked every chromosome, and there's a problem with the last one. All right, we got to repair it. Very good. All right, now our needle on our gauge has gone to the M. And what do we have to do in the first step of mitosis? Well, we better go ahead and separate those chromosomes, right? That's the only thing that makes sense here. There goes the centrosomes to each side. Our chromosomes are now attached to the spindle fibers. And we're in checkpoint 3. Let's check that. Are the chromosomes attached to the spindle? Looks like our cell's being checked right now. And the checkpoint is cleared. Okay, that's good. All right, is there anything else? All right, checkpoint cleared. And at this point, chromosome separation. Cell division would be next, right? Cell is dividing. There it goes. We filled in the empty gap from that cell that died. All right, what's left over? Let's see here. The cell cycle is strictly controlled, so the daughter cells produced are exact copies of the mother cell. It's important that the different phases of the cell cycle are precisely coordinated and that the phases follow in correct order. Coordination errors may lead to changes in the chromosomes, mutations. Chromosomes or part of the chromosomes may be lost, rearranged, or distributed unequally between the 2 daughter cells. Okay, so we can see we have a cell here with a mutated chromosome. That seems to be what they're referring to down there. Here we can see the cell cycle G1, synthesis, gap, and then mitosis, kind of like a summary flow chart. And here we go. It's giving us some questions here. It says, stop. Are you big enough to proceed? That's what happens in the gap 1 checkpoint. Little narration down below. In order to ensure that only faultless cells divide, there are special supervisors who are CDK and cyclin that make sure everything proceeds in the right order during the cell cycle. If something's wrong with a cell, they pull the brake and repair the damages before letting the cell proceed. Or they see to it that damaged cells are destroyed. Okay. Very good. If the supervisors are not working properly, the cells may become cancer cells, which have altered chromosomes. They may divide uncontrolled and much too fast. These mutated cells finally form a clump, a tumor. Understanding the control mechanism of the cell cycle is necessary for understanding how, for example, cancer arises. All right. And here we have an example of a tumor mass, multiple cells that have errors that are clumping up and piling on top of each other. All right. So it says, are you worried about the control of cell division in your body? The fact is, it's very rare that anything negative happens, and the supervisors do a good job. Do you want to see a short film of a real cell division? Well, of course we do. Click on the button above. All right, let's check it out. Oh, very nice. That was so good. Let's do it again. Clearly, we got some prophase going on here. Got them headed towards the middle before they pull away in anaphase and telophase, and then we'll have two complete cells one last time. Awesome. The end.